Good morning, everyone. Today's topic is analog to digital converters. In analog to digital converters, counter method. First, analog signals is nothing but it will be amplitude of analog signals will be changed continuously with respective of time, whereas digital signals is nothing but it is discrete signals, that is nothing but it contains the values of binary 1 and binary 0, binary 1 indicating high value and binary 0 indicating low value. So it is nothing but the noise in analog signals is more compared with digital signals. The digital signals, the main advantage is noise will be reduced in digital signals. So we have some different types of A to D converters and D to A converters. A to D converters is nothing but we are converting analog voltage into digital levels. Our D to A converter is nothing but digital input will be converted into analog output. The analog output is in terms of either voltage or current. So first, analog to digital converters, they have different type of methods: counter method, successive approximation method, parallel method, flash method. Whereas digital to analog converter have two methods. One is the binary weighted resistor method and second one is the R2 2R ladder network. These are the topics we covered in previous classes only. Digital to analog converters methods, binary weighted and R2 2R ladder network. So in today's class I am going to explain analog to digital converters by using of counter method. First, analog to digital converters is also known as A to D converters or ADC. ADC or A to D converters. It produces a digital output. So, analog to digital converter. So, analog is the input value and digital is the output value. Analog is input is nothing but the input is in terms of either voltage or current. It will be converted into binary levels, that is equals to zeros and ones, that is nothing but the analog input is converted into digital output. So analog to digital converter or ADCs, or it is also known as A to D converters. It produces digital output that is proportional to analog input, that is nothing but that is proportional to value of input analog signal. So when analog signal is processed by a digital system, an analog to digital converter is used to convert an analog voltage into digital form suitable for processing by a digital system. So analog signal is first processed by a digital system. By using of analog to digital converter, we can convert analog voltage into digital form by suitable processing into digital system. Analog to digital converters are, it can be, the analog signals can be continuous and it provides an infinite number of different voltage levels, whereas in digital the main advantage is it have finite number of values. The finite number of is nothing but it contains only binary ones and binary zeros. That's why it is called digital signals, is also called discrete signals. Whereas analog signals will be changed continuously amplitude with respective of time and it occupies infinite number of levels. The infinite number of levels causes more noise. The output of analog signals will be more noise. So noise reduction purpose, first we are limiting the amplitude limitations. Amplitude limitations is nothing but we can get imperfect signal at output section. If at all we are limiting the amplitude, we can get imperfect. That is nothing but noisy signal or different signal. The output will be different with input signal. So while analog signal is can be continuous and it provides infinite number of different voltage levels, the digital circuits on the other hand, it work with binary signals which can contain only two discrete stages, that is nothing but a logic 1. The logic 1 it indicating the high level and the logic 0 it indicating the low level. whereas in analog signal it have infinite number, in digital signal logic 1 and logic 0. So it is necessary to have an electronic circuit which can convert between two different domains of continuously changing analog signals and discrete digital signals, whereas an analog, and this is where we are using in analog to digital converters or A to D converters. The A to D converters are used for converting continuous changing of analog voltage into discrete output or digital output, two different domains continuously changing analog signals into discrete signals. So analog to digital converter or the need of A to D converters is what is nothing but analog to digital converters. It allow microprocessor controlled circuits, Arduinos, other digital logic circuits to communicate with real world microcontrollers or Arduinos. Arduinos are used for simple electronic equipment simple electronic experiments purpose. Next, and other digital logic circuits are communicate with real world. In the real world, the analog signals are continuously changing the values which come from various sources and sensors which can measure sound. The analog signals can measure sound, light, temperature or movement, and many digital signals are interact with environment by measuring the analog signals from such transducers. The digital signals measure the analog voltage by using of transducers. The analog signals, the values of sound, the analog signals which can measure sounds, light, temperature and many other different devices. So the digital signals can interact with analog signals by using of the transducers. So this is the circuit. So in this circuit, first this is the analog input signal. The analog A to D converter input is the analog input. So the analog signal is nothing but it will be continuously changing the values. So the amplitude of analog signal will be continuously changed with respect to of time. So the input of analog signal will be given to analog to digital converter electronic circuit. So the A to D converter, the need of A to D converter is nothing but it can convert an analog input into digital output. This is the output signal. The digital output, it contains only two levels. One is the binary 1. This is the binary 1 and this is the binary 0. Binary 1 indicating high position and binary 0 indicating low position. So by using of A to D converter or analog to digital converter electronic circuit, we can convert an analog input voltage into digital output. The analog input will be continuously changing with the analog input amplitude will be continuously changing with respect to of time, and it will be converted into digital output. So what is ADC? ADC is nothing but analog to digital converter is an electronic device that can convert continuous analog input signal into discrete digital signal. So analog signal is nothing but it will be used in real world signals that can contain noise. Just now only we can discuss the analog signals contain more noise compared with digital signal, and it is also continuously changing with respect to of time. The analog signals will be changing continuously with respect of time. So this is the analog signal. So in analog signal, the analog signal is continuous and it can change continuous in time and value. The analog signal is continuous in time and value. So analog signals is nothing but we can take the graph time versus voltage. So by if at all time varying, the time will be continuously varied and the voltage levels are the amplitudes of the signal also continuously changed. So whereas this is the discrete signal or digital signal. The digital signal is the discrete in time and value. So discrete in time and value, same, it is also taken time versus voltage levels only, but it contains only two levels. That at all time will be changed. It can move from either binary 0 to 1 or 1 to 0, means it will be changed from low level to high level or high level to low level. The digital signals is the changing with respect to of time movement. The changing movement will be is only only in between ones and zeros. So digital is nothing but discrete in time and value. The discrete is nothing but it will be changing only ones and zeros. The binary digit, the values it contains only either 0 or 1. So here the amplitude will be continuously changing with respective of time. Here also it will be continuously changed by the change, but the changing is only in the between 0 to 1 and only. That is nothing but logic 0 to logic 1 is nothing but low level to high level only. There are various type of analog to digital converters. The main various type of analog to digital converters is, first one is the successive approximation register, SAR, successive approximation register type analog to digital converter, and second one is the delta sigma. This is the symbol of delta sigma, delta and sigma, delta sigma analog to digital converter, and third one is the dual slope analog to digital converter. Fourth one is the pipelined analog to digital converter. Fifth one is the flash type analog to digital converter, or this is also called flash type analog to digital converter is also called simultaneous analog to digital converter, or it is also known as parallel ADC, parallel type analog to digital converter. So flash type, or it is also known as simultaneous or parallel type analog to digital converter. Next one is the tracking type analog to digital converter. Next, single slope. Here we are using one dual slope and single slope. The dual slope also analog to digital converter method, and single slope also analog to digital converter method. And the last one is counter type. The counter type analog to digital converter is also known as staircase or step ramp analog to digital converter. Staircase or step ramp analog digital converter. So these are the various types of analog to digital converters: successive approximation, delta sigma, dual slope, pipelined, flash type. Next, flash type is also known as simultaneous or parallel type. Next, tracking type, single slope, and also dual slope. Both are using for conversion analog to digital type. Next one is the counter type and also known as staircase ramp analog to digital converter. So now I am going to explain counter type analog to digital converter. Before going to start counter type analog to digital converter, we are already completed about analog signal and digital signal and analog to digital conversion. So analog to digital conversion purpose, we are taking one electronic circuit. The electronic circuit input is the analog signal, and which will be converted analog input into digital output. The analog input is in terms of voltage or current, and the main disadvantage of analog signal is it will be changed continuously with respect to of time. That is nothing but the amplitude will be changed continuously, and analog signals contain more noise compared with digital signal. Here we are using an electronic circuit type of ADC or A to D converter, or it is also known as analog to digital converter. So the analog to digital converter which can convert an analog input into equivalent digital output. So conversion of ADC or the electronic circuit of ADC is nothing but it are different types of ADCs: counter, successive approximation, pipelined, flash, parallel. Next, flash also parallel, tracking, single slope, dual slope. So now I am going to explain counter type analog to digital converter. So in counter type also we are giving analog input and we are getting the digital output only. But how it can change analog input into digital output, or what are the process involved in analog to digital converter by using of counter method. Now I am explaining. Counter type ADC, it is also called a digital ramp ADC. That's why it is called staircase or step ramp. So counter type is also called staircase or step ramp, or it is also known as a digital ramp. Staircase, step ramp, digital ramp ADC, because the output ADC is nothing but the output of analog to digital converter is step by step ramp, step by step procedure. That's why it's called digital ramp or staircase or step ramp method. So it is also called a digital ramp. That is nothing but the output is in terms of a step by step ramp. The output is in the form of step by step ramp. The analog signals is to be converted the analog signals to be converted, it is applied to the non-inverting terminal and the output of DAC is applied to inverting terminal of Amp Comparator. So first the analog signal is converted and applied to non-inverting terminal and the output of digital to analog converter. First analog signal is connected to analog signal is applied to non-inverting terminal and the digital to analog converter output is applied to inverting terminal of Amp. So first the Amp it consists of two inputs. One is the inverting input and non-inverting input. So the inverting input will be connected to output of digital to analog converter and the non-inverting input is connected to analog input. Next here the Amp it work as a comparator type Amp. Amp applications mainly it work on adder, subtractor, integrator, differentiator. It also work as comparator or Amp. By using of Amp we can convert voltage to current or current to voltage. So here we are applying the comparator type Amp. The comparator type of Amp is also consist of two inputs. One is the inverting input and second one is the non-inverting input. The inverting input will be connected to output of digital to analog converter and the non-inverting input is connected to analog input signal. Next, the comparator. The main aim of comparator is nothing but the comparator is a type of Amp which compares the analog input voltage and DAC output voltage. So the Amp comparator type it consists of both analog input and output of DAC output voltage. Just now only here we can discuss that. So the comparator is nothing but it consists of output of DAC is applied to inverting terminal and also analog signal. So here the comparator compares the analog input signal and output of DAC. Next, the analog input voltage is greater than DAC. The DAC output, digital to analog converter output is connected to inverting terminal of Amp and non-inverting is connected to analog input. So if at all the analog input voltage is greater than digital to analog converter output, so the output of comparator it can change into high position. The output of comparator is indicating high value. So the analog if the analog input whenever it indicates high value is nothing but the analog input voltage, that is nothing but non-inverting input voltage is greater than inverting input voltage. Non-inverting input voltage is nothing but the analog input voltage is greater than digital to analog converter output. So the comparator it indicates high position. Otherwise if the analog input voltage is less than, that is nothing but non-inverting input voltage is less than inverting input, that is nothing but digital to analog converter output. So the analog input voltage is less than digital to analog converter output voltage. So the comparator, now the time comparator it indicates low position. The comparator indicating high position only in the case of analog input is greater than digital to analog converter output, or analog input is less than digital to analog converter output. The comparator it indicates low position. A counter type ADC it produces a digital output which is approximately equals to analog input by using of counter operations internally. So counter type it produces digital output. The digital output is nothing but it will be either binary 0 or 1 which is equals to analog input using analog input by counter operation internally. So this is the circuit. First, counter type ADC mainly consists of clock signal. So it is consist of, this is the clock signal. Counter type ADC mainly consists of clock signal generator and counter. Next, this is the counter. Next one is the digital to analog converter. Next, comparator. So this is the digital to analog converter, DEAC, digital to analog converter. Next one is the comparator. This is the comparator type Amp. So it mainly consists of one is the clock signal, second one is the clock signal, after clock signal generator, counter, next counter after, next DAC, digital to analog converter, and this is the comparator, and the output, next the output of counter is applied to input of DAC. This is the output of digital to analog converter. The output of digital to analog converter will applied to Amp comparator type. This is the Amp comparator. So Amp comparator, it consists of analog input voltage as well as it consists of digital to analog converter output voltage. So the output of counter is applied and input of DAC. First the output of counter, this is the output of counter, and it will be applied to input of DAC, and the output of DAC will be applied to input of comparator. Next here we are using op-amp as a comparator. This is the op-amp comparator. Next, ADC is an electronic device, or that is nothing but analog to digital converter is an electronic device that changes an analog input current or voltage. The analog input is in the form of either current or voltage to a digital number representing the magnitude of voltage or current. This is the binary digital numbers. The digital numbers, it indicating the magnitude of voltage or current. Normally the digital output is the 2's complement or 2's complement binary number that is relative to the input, but there are other possibilities also. So first, normally the digital output is nothing but B0, B1, B2, B3. So the digital outputs is 2's complement of binary number, 2's complement of binary number that is relative to input, and also some other possibilities. So this is the general counter type block diagram. The how we can draw the counter type block diagram is nothing but first it contains the op-amp comparator. The op-amp comparator output is given to AND gate and AND gate to counter. Next, the counter output will be applied to digital to analog converter input. The counter output is applied as a digital to analog converter output, and the digital to analog converter output is applied to again comparator. So the comparator, it consists of the op-amp comparator, it consists of analog input as well as the DAC output. Just now only we can discuss if the analog input voltage is greater than DAC output. Analog input voltage is, just you can observe here, the analog input voltage is connected to non-inverting terminal of op-amp. The inverting terminal of op-amp, why? Because it is called non-inverting, nothing but it will be connected to positive input. The positive in op-amp, it indicating the non-inverting terminal, and the negative sign it indicating in op-amp is inverting terminal. So first we are applying the analog input voltage VA. Here the VA is the analog input voltage. So the analog input voltage is connected to non-inverting terminal of op-amp, and the inverting terminal of op-amp will be connected to digital to analog converter output. So digital to analog converter output and the non-inverting terminal input voltage will be connected to comparator. The property of comparator or the aim of comparator is nothing but which can be used for comparing purpose. So first it can compare the analog input voltage with digital to analog converter output voltage. So first it can check the analog input voltage and digital to analog converter output. So if at all analog input is greater than digital to analog converter output, so it indicating the binary 1 position. The binary 1 will be goes to counter. If at all it will be 0, or that is nothing but analog input voltage is less than digital to analog converter output, so it indicating 0 position. So working of counter type ADC is nothing but first let us assuming the internally counter is reset. First the counter will be resetting and the output of digital to analog converter is 0. In first case counter will be resetting. First let us assuming initially. So first initially the counter is in resetting position and the output of DAC is equals to 0. The output of digital to analog converter is 0. Since the analog input is greater than initial value of output of digital to analog converter. First the initial value of digital to analog converter is what? It will be as 0 volts. The output of digital to analog converter initially 0 volts. That is nothing but at reset counter resetting time the counter value is 0. That is nothing but digital to analog converter input is 0 and output also 0. So first we are applying in analog input. Analog input is applied to non-inverting terminal of comparator. That is nothing but non-inverting terminal of op-amp, and the DAC value initially it will be 0. That is nothing but digital to analog analog converter, at resetting time it indicates 0. So since the analog input is greater than the initial output of digital to analog converter, the initial output is 0. That is nothing but digital to analog converter value is VB. Digital to analog converter is VB. Next, analog input voltage is VA. So VA is greater than VB. VB is nothing but digital to analog converter output value. So the digital to analog converter output is less than analog input, or analog input is greater than digital to analog converter. Here VA is the analog input and analog input of comparator, and VB is the output of digital to analog converter. Next, the output of comparator is high and the AND gate is enabled. Whenever it is high, the value of VA is greater than VB. That is nothing but the initial value, that is nothing but non-inverting terminal of op-amp value will be high, greater than inverting terminal. That is nothing but analog voltage value is greater than digital to analog converter. Next, the comparator compares and it will be greater than, analog voltage is greater than digital to analog converter output. Then the AND gate will be enabled. The output of the comparator is high. High is nothing but it indicated by the binary 1. Here it indicating binary 1. Next, the comparator is high and AND gate is enabled. This is the AND gate. AND gate is enabled, so the clock pulses are transmitted to the counter. So AND gate inputs are, first is the comparator output applied to AND gate, and the second one is the clock pulse. The inputs of AND gates is clock pulse and the output of comparator or output of op-amp. So both the inputs are applied to AND gate. Whenever the AND gate is enabled, the output of comparator is high and AND gate is enabled. The clock pulses are transmitted to counter and the counter starts to the coupling. So whenever the clock pulse is started to applied to AND gate, the counter will be counting. The transmitted to counter and the counter starts counting or coupling. Next, the output of the comparator is digital. The output of comparator is digital and it will be converted into reference analog voltage by using of DAC. So the digital value is depends on the reference analog voltage, digital to analog converter DAC. The counter counts as long as VA greater than VB. So VA greater than VB only the counter is used for counting. So in this case only the counter works on the counting purpose. When the DAC output is greater than analog signal, so that is nothing but DAC output is more than the analog input voltage, and that case is called VB greater than VA. In first case VA greater than VB, here VB is greater than VA. So the digital to analog converter is output is greater than analog signal. The comparator it indicates low position. The output of comparator or the output of op-amp it indicates low value. In first case output of op-amp indicated by high value, here the output of op-amp indicated low, and low value means the AND gate is disabled. In first case AND gate is enabled. Whenever AND gate is enabled, analog input is greater than DAC output. Here the analog input is less than digital to analog converter output. That is nothing but VB is greater than VA or VA less than VB. Analog input is less than digital to analog converter output. So in this case the comparator output is low position and the AND gate is disabled. In first case AND gate is enabled, here the AND gate is disabled. So the clock pulses do not reach the counter and the counter will be stopped. The clock pulses only AND gate enable condition only the clock pulses are reached to the counter and the counter will be starts counting. Here the clock pulses do not reach the counter and the counter will be stopped. The process of counter is stopped. Next, the count it reached the digital output is proportional to analog input. The counter when it stops counting only analog gate is disabled, and next the counter it reaches the digital to output proportional to the digital to output value is proportional to analog input. So this is the counter type ADC, the digital counter type analog input. Counter is nothing but first the analog input is compared and it will be transferred to AND gate, and whenever AND gate works and enable function and disable function. The enable is nothing but the comparator indicates high position, counter is in enable position, and the AND gate is enable position, and the counter is starts counting. Whenever the AND gate is disabled, that is nothing but analog input is less than digital to analog converter output, and it will be disabled. The AND gate is disabled and counter will stops the counting. So this is the total process of counter type ADC. The counter next, whenever AND gate is disabled, the comparator output is low, the AND gate is disabled, the clock pulses do not reach the counter, so the counter will stops the counting. The clock pulses do not reach the counter, and counter performing stops the counting. So the counter reach the digital output is proportional to analog. This is the input and output waveforms of counter type analog digital converter. So here we are taking the analog input. This is the analog input. The analog input will be converted into digital value. The analog input is nothing but the values of analog is nothing but it is different voltage levels. These are the different binary. Y-axis contains the digital outputs. The digital outputs is nothing but it contains the binary numbers 001, 010, 011. 001 is nothing but it relevant to analog input voltage 0, 010 indicating 2, 11 indicating 3, 100 indicating 4, 1015, 1106, 111 indicating 7 value. So this is the analog signal. Analog signal will be changed and the changing value will represent in the digital form. This is the DAC output, 3-bit DAC output. Next, 7 transactions for its complementing position. 7 transactions is nothing but here we are starting from 0 to 7. 0 indicating the binary 0 is nothing but 0. Next, analog input 1 is indicating 001, 010. So this is the almost 7 bits. Analog input versus digital output. The analog input here we are taking in x-axis and the digital output we are taking in y-axis. So that the graph of analog to digital converter is nothing but it will be like staircase, and that's why it is called staircase or ramp type. Digital ramp or staircase. So counter type is also known as staircase output or digital type. Counter type, one of the simplest type of analog to digital converter. Analog to digital converter is the counter type ADC. Simple form or easiest method of analog to digital converter is counter type. Next, the input signal of analog to digital converter is connected to signal input of internal comparator. That is nothing but VA. Here we are taking the analog input voltage VA. That is nothing but the input signal of ADC is connected to input of internal comparator. Internal comparator is nothing but here we are taking the Amp. So the Amp input is the analog input. Next, the ADC then systematically increases the voltage with voltage of the reference input of comparator until the reference becomes larger than signal. So ADC is nothing but analog to digital converter. First, systematically increase the voltage of reference input. So whenever VA is greater than VB, so it will be is nothing but the comparator indicates high position and it will be go to AND gate. AND gate will be enabled and counter will be starts counting. So the analog input is greater than time only. The reference input of comparator will be comparing until the reference becomes larger than signal. If at all reference is nothing but VA is less than VB, then counter stops counting. The reference becomes larger than signal only. This is the block diagram. So here we are using clock pulse, control logic, counter. The counter type will be applied to, the counter output is applied to DAC input. So digital to analog converter. Digital to analog converter, again it will be connected to Amp comparator. So the Amp comparator, it consists of inverting input and non-inverting input. First is the analog input signal and the next one is the digital input signal, clock signal and control logic. So here the reset and start counter. Reset and first start the counter. So whenever counting starts, only analog input is greater than digital to analog converter output. So DAC convert digital output of comparator to analog signal. Compare the analog input and output of DAC. If VI is less than VA, DAC continuously counting. VI is equals to VD, the DAC stops. So digital output is nothing but output of comparator. Main disadvantage is conversion time is varied per 2 power n clock pulses required for full scale input. So counter time advantages is the counter type. So counter type main advantages is nothing but counter type ADC is the first, very simple, easy to understand, simple to operate. So it requires less number of blocks. One is a AND gate, and next one is a general purpose amp. It works as a comparator, and the next one is a comparator DAC, digital to analog converter bit, and next one is the clock pulses. It requires clock pulses, AND gate, next AND gate after the counter, digital to analog converter output, next one analog input voltage. It requires op-amp type of comparator. So it is a simple circuit. Mainly it consists of op-amp comparator, AND gate, next counter, and digital to analog converter block, and digital to analog converter block. So counter type ADC is a very simple, easy to understand, and also operate. Counter type ADC designs less complex, so the cost is less. It requires minimum things, so that is nothing but op-amp, A to D op-amp, after op-amp, next AND gate after counter, after DAC. So design is design complexity is less, and it requires less number of blocks. So the cost of a circuit also less. It requires less number of blocks, circuit complexity less, and cost is also less. In the counter type ADC 4-bit conversion, the 4-bit converter conversion time is 15 clock pulses. How we can get 15 clock pulses is nothing but in ADC the conversion is nothing but it requires 2 power n minus 1 bits. That is nothing but the counter type ADC for 4-bit converter 2 power n minus 1. 4-bit converter is nothing but 2 power 4. N is equals to, here n is equals to 4. So 2 power 4 minus 1. The conversion time of 15 clock pulses it required. For 4-bit conversion it requires 15 clock pulses. That is nothing but the requirement of clock pulses is depends on the 2 power n minus 1 bits. Here n is equals to 4 bit. The 4-bit counter requires 15 clock pulses means 2 power 4. The 2 power 4 value is 16. 16 minus 1 is equals to 15. So 4-bit counter requires 15 clock pulses. For 8-bit conversion time it requires 5 clock pulses. That is nothing but 2 power 8 minus 1. 2 power 8 indicating 256. 256 minus 1 is nothing but for 8-bit conversion it requires 255 clock pulses. For 4-bit conversion it requires 2 power 4 minus 1 is nothing but 15 clock pulses. For 12-bit conversion it takes 4095 clock pulses. 4095 is nothing but first it requires 4096 minus 1 is nothing but 4095 clock pulses. Next, counter type ADC main disadvantages is nothing but advantages in simple circuit, easy to build. Next, cost is less, easy to operate, requires 2 power n minus 1 clock pulses. So based on n number we can require the clock pulses, or we can get the clock pulses. If at all 4-bit we can get the clock pulses as 2 power 4 minus 1 is nothing but 15 clock pulses. Counter type ADC the main disadvantage is operation is slow and the conversion time is large. Next, speed is also low since each time the counter has begin from 0. Each time we can resetting the counter and it will be starts from 0 position. So slow operation, time taking, conversion time is large. Conversion from analog to digital time, conversion time is nothing but. Next, speed is also less. Next, each and every time we are resetting the counter is nothing but 0 position. There are many conflicts in the next input is sampled before completion of one process. So this is the main disadvantage. Slow time, first operation slow, maximum time it takes, and maximum time is nothing but it takes, thus conversion speed is less. Next, each and every time we are ensure with 0 position. Next, the next input sampled before the completion of process. So this is all about counter type analog to digital converter. So here we are some multiple choice questions will be there. The multiple choice questions are related to counter type analog to digital conversion and the definition relates to analog to digital conversion. So first question, at what condition digital to analog conversion is made? At what condition? First here we are taking the one comparator. The circuit it consists of one comparator and gates, next to binary counter, next to digital to analog converter output. So this is like this, the circuit, the total circuit it represents, or the question number 1 it represents, it is a type of counter type ADC. Why we can say this is the counter type ADC is nothing but here we are applying the inputs to comparator type op amp. The comparator type of op amp, it consists of analog input to non-inverting terminal, and the DAC output is connected to inverting terminal of op amp. The comparator output is we are giving to next AND gate to again AND gate output is applied to binary counter, and binary counter output is applied to input of DAC. So the total circuit it represents as a counter type ADC. At what condition digital to analog conversion is made? In counter type only the conversion is VA greater than VB. So when VA greater than VD, the output of the comparator becomes low and the AND gate is disabled. So next, the stops counting, and the time the digital output of counter represents the analog input. So only VA greater than VB only the analog conversion is made, digital to analog conversion. So at what condition digital to analog conversion is made is nothing but this is the analog to digital counter type. So digital to analog is made on the VA less than VB. That is nothing but VA less than VB, the digital to analog conversion is made. So analog to digital conversion is nothing but VA greater than VD. VD is nothing but the output of digital to analog converter. VA greater than VD, that this method is used for conversion from analog to digital. A digital to analog conversion purpose, VA less than VD. That is nothing but the output of comparator becomes low. So it will be converted into digital to analog conversion mode, and the AND gate is disabled, that stops counting, and the time of digital to output converter represents the analog input voltage. Next, which among the following long conversion time? Long conversion time is nothing but either servo comparator or dual ramp converter, or C is the flash converter, D is the none of mentioned. Just now only we can discuss in counter type ADC disadvantage. The counter type ADC main disadvantage is operation time is slow and the conversion time is too large. Operation is slow, conversion is large, and speed is also less. So and also each time we are ensured with resetting position starts from 0. So just now only we can discuss the conversion time of counter type analog to digital converter is slow or low. Conversion time is maximum, conversion is maximum, and operation is slow. So maximum conversion time is the main disadvantage of counter type. This is a question relates to same. Which among the following long conversion time? Conversion time is maximum in counter type ADC, the main disadvantage. So by comparing all above, servo converter or dual ramp converter, flash converter, so the main conversion time is high in dual ramp converter. The main disadvantage of dual slope converter is nothing but long conversion time. So for instance, it requires for 2 power n minus 1 is nothing but 1 by 50 used to pick up the 20 milliseconds. So t is equals to 50, it takes the 20 milliseconds of time. That is nothing but the dual ramp converter, it takes the large conversion time. This is all about counter type analog to digital converter or dual ramp. So today's class we are completed about analog to digital converter definition. Next, analog to digital conversion, it produces analog input related to digital output. Next, the digital output contains binary 1s and 0. The analog input will be changing continuously with respect to of time. So by taking one electronic circuit type count analog to digital converter electronic circuit, we can convert analog signals into digital values. The analog signals is nothing but it will be continuously changing time. Digital contains only 2 levels. There are some different type of analog to digital converters like SAR, successive approximation, delta, sigma, dual slope, pipeline, simultaneous, parallel, or it is also known as flash, tracking, single slope, counter. Today's class we are completed about counter type, or it is also called staircase, ramp type, or digital ramp. So in counter type, it is a simple circuit. It will be built by using a Amp Comparator and Amp Comparator. After we are taking an AND gate will be connected to counter, and counter output is connected to digital to analog converter output, and the digital to analog converter is also again applied to comparator. So the comparator, it consists of 2 inputs. One is the analog input and second one is the DAC output. So first here the non-inverting terminal will be connected to analog input voltage and the inverting terminal of op-amp will be connected to DAC output. DAC output is nothing but digital to analog converter, output is connected to inverting. So first if the input voltage is greater than, that is nothing but VA input is greater than DAC output, then the AND gate is enabled, and whenever AND gate is enabled the clock pulses are transmitted and it will be reaches to counter. The counter is used for starts for counting process. Whenever the analog input voltage is less than digital to analog converter output, so it indicates AND gate will be low, so the output will be indicate the comparator output is indicating low position and AND gate is disabled. Whenever AND gate is disabled, the counters clock pulses doesn't reach to counter, so the counter will be stops counting. So whenever comparator is high position, that is nothing but analog input is greater than DAC output, that's only condition AND gate is enabled and clock pulses are transmitted. AND gate is enabled, clock pulses are transmitted to counter and counter is starts counting. The AND gate is low, that is nothing but the AND gate whenever low is nothing but it disabled is nothing but only the condition of comparator is low. Whenever comparator is low is nothing but analog input is less than digital to analog converter output. The condition comparator indicating low position. Next the comparator low is nothing but AND gate is disabled. The clock pulses do not reach the counter. That's why counter stops counting. So this is the operation involved in counter type ADC. This is the counter type ADC comparator. Next comparator after AND gate, counter, DAC. The main advantages are it is a simple circuit, easy to construct, it requires less number of bits and circuit complexity is also less. Next it requires 2 power n minus 1 clock pulses, that is nothing but for 4-bit conversion it requires 2 power 4 minus 1, that is nothing but 16 minus 1, 15 clock pulses. Or 8-bit purpose 2 power 8 minus 1 is nothing but 256 minus 1. So for 8-bit conversion it requires 255 clock pulses. So simple circuit, easy. And next counter type is circuit, or it requires less number of bits, easy to operate. But the main disadvantage is the operation is slow and the conversion time is too large. Conversion time is more and operation is slow. Next, each and every time we are ensure with in your 0 position resetting counter and it will be starts from 0 position. This is the main disadvantage. Operation slow and takes more conversion time. These are 2 multiple choice questions related to a counter type ADC. So next class will discuss about remaining types of analog to digital converters like successive approximation method. Thank you all.